And good afternoon, ladies and gentlemen. During this talk, I hope to answer 5 questions. Who is SER and who are our partners? What led us to Queensland? What did we realise once we got there? Has it all been done before, and what is the way forward? SER is a junior explorer and project generator, and we're focused on the discovery of copper gold undercover in greenfield frontiers of Australia. Our key project areas are within the Gawler Craton in South Australia, the emerging East Tennant IOCG province in the Northern Territory, and most recently, we've moved into the Mount Isa province of Northwest Queensland. We're focused on exploration. We don't have the aspiration to become a developer, and we're willing to work with larger partners to help share the risk and keep us exploring. We have a strong belief in research-informed exploration, and we're a proud member of the Mineral Exploration Cooperative Research Centre, where we sit on the Science Advisory Committee. And we consider ourselves a lean, low-cost, multidisciplinary group of 5 of us who all wear multiple hats. For example, I'm a geologist in our JORC CP, but I'm also the company lawyer, the IT guy, and it always seems to be me who ends up taking all the petrophysical measurements as well. On the map in front of you, you can see some of our partners. The MinEx CRC is the world's largest mineral exploration collaboration, consisting of industry, government and research, and has over $200 million in funding to help discover the next generation of mineral deposits in Australia. Its work's divided into 3 programs, the first of which is developing faster, cheaper, safer, cleaner drilling, including a coiled tube drilling rig. Its second program is developing new technologies for collecting real-time data at the drill rig. And the third program is what's called the National Drilling Initiative. That's a massive stratigraphic drilling program to map the regional geology and architecture in new frontiers across Australia and define the potential for mineral systems. In fact, the National Drilling Initiative is underway right now at the first campaign in the East Tennant region in the Northern Territory. And we're very keen to see the results of that. On the Gawler Craton, one of our partners here is Caldera Analytics. Caldera Analytics is a data science pioneer, particularly in mineral exploration, and we're working together to search for IOCGs using a fusion of data science and more traditional geoscientific targeting methods. You may know of Caldera. They were the winner of OzMinerals Exploration Challenge last year, and they were the runners-up of the South Australian Government's Explore SA Gawler Challenge this year. So they've already had a lot of success using data science on mineral exploration. We're very happy to be partnering with them. And finally, also on the Gawler Craton at our Mile Creek Copper Gold project, we have a joint venture with Fortescue, who you will all know, a great Australian company in less than 20 years, have become one of the most significant mining powerhouses, $50 billion market cap, and are now looking to diversify into copper. In terms of our strategy as a company, this is how it was described by one user on the well-known stock forum Hot Copper. And in a sense, that's kind of what we were aiming for. In fact, when I saw this, it inspired me to go out and peg some new ground in frontier regions. So that's SER and our partners. What led us to Queensland? Well, the answer is the Saxby Gold Project. Essentially, 2 high-grade hits of significant width in the middle of nowhere. The exploration company that had this project was changing direction in the downturn to become a 3D printing company, and they were selling off their projects, and we had the opportunity to get that project at a very good price. I'd love to say it was the result of a comprehensive ground selection process. In reality, it was an opportunistic grab of these tantalizing gold hits that we thought deserved further follow-up. You can see where we are on this map here showing the outcrop in the Mount Isa province, magnetics in the background, continuing undercover up north of Cloncurry to Saxby, about 150 kilometres north. So let's take a look at Saxby. It all started in 2008 when Anglo-American were targeting intrusion-hosted nickel copper deposits undercover. They conducted a very cutting-edge SQUID EM survey over a vast area and targeted EM conductors. And you can see the discovery hole here, SXDD005, targeting conductors for nickel sulfides, but actually assays returned a very significant gold intersection towards the end of hole 17 meters at 6.75 grams per ton AU. We're at under about 400 meters of cover here, and the EM conductor was explained by a thick interval of graphitic metasediments above the gold mineralization. So it really was a serendipitous hit, for want of a better word. There's a picture of a polished slab here, and you can see the high-grade golds associated with this kind of coarse pyrite, and also that's cut by this carbonate, anchorite, siderite, and sulfide-bearing vein. That's where the really high-grade stuff is. That you can see that slab there is over an ounce per ton. Anglo-American immediately farmed the project out to a gold company, Anglo Gold Ashanti, who took over in 2009, came in and did some detailed geophysics, magnetics, gravity, did a lot of structural work on the core, and formed the view that the controlling structures for gold mineralization were northeast striking. And you can see this is their drill plan prior to their drilling campaign, where you can see the planned drill holes aiming to target that orientation. They drilled 5 holes, you can see on the right-hand map with the blue drill traces, and had a significant hit in hole 14, about 200 meters south of the hit in the discovery hole hit in hole 5, 8 meters at 15, another very significant hit. A lot of copper in many of the other holes, but ultimately Anglo Gold Ashanti decided it was too deep and likely too small for them. The ground fell back to the original junior, Falcon, and in 2012, Falcon came back in and drilled these 4 holes you can see with the green hole traces, and they were of the view that the mineralization was closer towards north-south or north-east, and you can see they were targeting that structure. Unfortunately, those drill holes in both the pre-collar and the diamond tail experienced significant steepening, and ultimately didn't reach or barely reached that target structure. They did encounter a large interval of intense alteration, and they did get some significant hits, but not enough to justify. Here's a picture here. You can see it's slightly less intense in the pyrite, but not enough that they didn't hit the key target zone, and ultimately the company pivoted away from exploration, allowing us to get the project. In the last year, we've come in, and the first thing we did was drill a quick, cheap hole directly in the middle of the 2 historic intersections that were 200 meters apart, just as a proof of concept before we came in and spent significant money on this. And that first hole there, hole 20, hit 6 meters at 12, which was enough for us to say, okay, we're going to have a very close look at this. We took a close look at the structural geology and formed the view that the key controlling structure for the brittle extensional veins that host gold is indeed north-northeast trending fault. It dips steeply to the west, and there's some evidence of west side upwards displacement during mineralization. Now, that model also helped explain some of the flatter lying and mineralized structures that were in different orientations that the earlier explorers saw, because as that fault moves vertically, it opens these dilational link zones that you can see illustrated here that fill with kind of breccias and stockworks in a more gently west dipping and shallow plunging link zones that would explain the two different orientations observed. We also got some proper Queensland geologists in to look at the hydrothermal alteration, and they told us that we were looking at a paragenesis that's quite typical of IOCG style systems in that Cloncurry region. Very most recently, we've come in, just finished a couple of weeks ago, drilling 3 more holes that you can see here, hole 21, 22 and 23, the pre-collar in yellow, the basement coring in blue, just seeking to step out from those hits and increase the strike. They're being sampled now and sent to the lab assays late November. So that's what got us to Queensland. And what did we realise once we got here? Well, many others have shown that this area north of Cloncurry that we're looking at has all the ingredients for a significant mineral system. There's the right crustal architecture following that Gidja suture zone north from Cloncurry, known as Henry. Further south, you can see here, this is gravity, pardon me, and that's also reflected in the magnetics. There's a big conductivity anomaly in that part of the world, and a number of seismic lines that confirm that. So we're on a transcrustal kind of structure. We've also got a lot of energy in the system in the form of high temperature bimodal magmatism, and that's not just inferred from geophysics. We've seen that in some of the very few drill holes that are here, and others have shown that with intrusion and alteration-based prospectivity mapping, that there are credible sources, metal sources and depositional gradients in this part of the world, not to mention the fact that we actually have high-grade mineralization intersected in drill holes. So we've come to the conclusion there is broader potential than just the initial Saxby small prospect that drew us here, and we want to take a closer look at this area that we're calling the Canobie District. So let's take a closer look. There's a very limited historic drilling here. So we've now gone ahead and pegged over 1,600 square kilometres of ground. You can see that on this map showing the outcrop and the deposits and occurrences in the shallow cover, and then heading north to the ground that we've pegged here. That little yellow dot is Saxby. There's only 33 holes that we can find in that whole area. 8 of them didn't hit basement, we're just targeting shales. So we've got 25 holes in 1,600 plus square kilometres that hit basement. Now 10 of them are at Saxby, so that's one prospect. 5 of them are at another prospect called Tea Tree, which is a nickel copper sulfide prospect with a significant intersection you can see there. So really, once you take those 2 prospects away, you're talking about there's only 10 regional basement intersecting holes in this whole area. Now, even within those 10 holes, there's numerous significant intersections of copper and uranium mineralization in isolated rocks in isolated drill holes within intensely altered rocks. and they're all single drill holes that were never followed up. So for us, that represents an extraordinary strike rate. If you were to think a part of the Gawler Craton with a comparable level of cover with these kind of prospects and hits and that strike rate, I would posit that it would be peppered with drill holes. So we saw an opportunity there. So I said to my exploration manager, please go out and peg it all and then go generate some targets. And he said, unfortunately, it's not that simple. So this video was taken late last year when we were drilling at Saxby. And as you can imagine, or as you can see, there's not a lot of vectors to mineralization. Now, we all know that there's been recent discoveries at depth. Havieron in Western Australia is under 400 metres of cover, a very similar setting. And Oak Dam on the Gawler is under at least 700 metres of cover. So we know we can target and discover at these depths. But it is hard, it's expensive, and juniors only have so much money and shareholders only have so much patience. But we decided to do it anyway. So here's where we're at most recently. We're using Dave McGuinness as our geophysicist. I'm sure many of you will know. We've reprocessed everything. We've defined prioritized targets using gravity, magnetics, the EM, the squid EM, structural, and the limited geology that we know from drilling. And we've also found, when we've reprocessed some of the historic geophysics and taken a closer look at some of the prospects, that there is evidence that some of the previous drilling may have been near misses. So we're going to have a much closer look at those, and those are holes with significant intersections of copper that that we think warrant follow-up. So that brings me back to the topic of this session, which is innovation. And is what we're trying to do here really that new? Has it all been done before? Well, it turns out it has. So WMC held this ground. I'll just show you this blue tema up here is covering our ground up at Saxby. They held this ground when I was 9 years old, and they used a very similar process of defining, prioritizing and drill testing geophysical targets, and discovered the giant Ernest Henry deposit on the southern tenement you see here that I'm sure you're all familiar with. So perhaps we're not as innovative as we think, or perhaps innovation, a little bit like exploration, is an incremental process. Sure, sometimes there is a spectacular hit on the first drill hole, but more often it comes down to perseverance, and the more drilling you do, the luckier you seem to get. So my final question is, what is the way forward? I see innovation and discovery as a process, and in our view, pre-competitive data, interpretation and the research that goes along with it is part of that process, and juniors like us cannot live without it. We can't do it on our own. We need help, and we'd love to work with you. I'd also like to emphasize the incredible work that the Mineral Exploration Cooperative Research Centre is doing. It's important work, and it's going to help discover the next generation of mineral deposits. And I will humbly suggest that Queensland should seriously consider upgrading to full membership of the MinEx CRC and bring the National Drilling Initiative to Queensland to map the basement in covered terrains and open the search space. In fact, I reckon I know just the place you can start. Thank you very much.
Nice one. Thank you. And look, watch this space for MinEx activities in Queensland. You just never know what's going to happen. But agree that exploration undercover such a challenge, and it's been recognised for decades now as the challenge, and yet we don't seem to have really cracked it. So I'll give the audience a chance to put any questions in the Q&A, if they in the Q&A tab at the bottom of your screens, if you would like to. Give everybody some awkward silence. Otherwise, if you think of anything while you're talking, or while we're talking, oh, here's one. Now, Karen Connors is asking Stuart if you've done any geochronology.
Thank you, Karen. We have not, but we understand the GSQ have dated one of the granodiorites from one of the holes at Saxby, and we have an understanding of that date, and that understanding has reinforced our view regarding those energy systems and metal sources. I can't go into further detail because we haven't put those dates out. Helen, do you have any further background on that?
Look, Dave Purdy and Dom Brown and Bob Bolstude have been working on that geochronology, and I couldn't tell you the dates off the top of my head, but I'm not sure if they're in the audience. I didn't check for their names, but definitely something that will be coming out in. I know they're writing up all of that geochronology now, so it'll be coming out as a GSQ record in the next few months.
Yes, from what I know, yeah, granodiorite sample from hole 14 was dated by shrimp, uranium lead zircon at 1539 is what I've heard, but we haven't officially released that.
Well, as it's a GSQ date, it's public, so yeah.
Okay, perfect.
Yep.
I had a question. Looks like there's other ones there actually.
There are, but you go ahead, Rick.
I was just going to say, have you with the extra drilling that you've done and looking, are you finding that the gold mineralization is associated with a particular host rock, or is it a zone that's actually cross-cutting stratigraphy?
It is not associated with a particular host rock. It does cross-cut. It does seem to go in many different units. It seems to favour more brittle units. But no, we see it in multiple different units.
And are you getting any iron oxide associated? I saw there's lots and lots of pyrite, but are you getting any iron oxide? And if so, is that iron oxide hematite or magnetite?
Yes, we are. We're seeing iron oxide hematite kind of dusting on some of the potassic alteration, and then we're seeing a variant of magnetite, bit more dominant.
Great, thanks.
I'll go through these questions because we do have a couple of minutes left. Mike Whitbread is asking how many of the holes, or how much of each hole was assayed, and how extensive is the assay suite?
Our holes that we've drilled, we're assaying every metre, and we're using a 4-acid digest, or fire assay for gold, 4-acid digest, and then kind of 60 plus element suite. So we're going the full Rolls Royce on our holes, and we're actually going to cut a further 800 metres of historical holes that were never assayed and do the same.
Awesome.
Yeah, so we're going very hard on the assays, and with the historic holes, a lot of the digest was aqua regia. So we think that we might be able to see a bit more with that 4-acid digest.
Great. And then another attendee has asked, what have you found to be the most useful geophysical techniques for targeting undercover deposits?
That's a great question, and one that I can talk about for a very long time. At that Saxby gold prospect itself, not a lot. Magnetics helps, but it's not fine enough. So we're almost just doing traditional step-out drilling. Then more regionally for the greater district, gravity seems to be very powerful, but then combined with mag and conductivity EM.
Mark Twining is asking, any thoughts or work on the minimum target size to be viable at that depth?
It has to be big, no question. You know, not wanting this to be construed as a JORC exploration target, but so, you know, 1 million ounces or more would be something that I think would be appropriate.
Great. Anusha is asking, great presentation, or saying great presentation and solid concept. It would be a deep deposit, so expanding on the last question, it would be a deep deposit to discover in future. So this is a similar question, sorry. What is the target size that would make it economic to mine? So we've sort of already covered that.
Very good.
Richard Blewett, who's meant to be on holidays, is saying great talk and great to see that GA data is being used in your mineral systems targeting, and I'll second that. And thank you again from all of us for the plug for pre-competitive data at the end as well. We certainly appreciate that. Richard is asking, what additional pre-competitive data would you like to see in the region for or from GA and GSQ?
That's a great question. Thank you, Richard. And we've been discussing this with our neighbours, Red Metal to the north and South 32 have also got some ground there. And gravity is a gravity and gradiometry are a fantastic data set. It's kind of gravity never lies. So detailed gravity, consistent gravity would be a fantastic one. You know, 3D seismic is another data set that's getting used a lot in WA. And the MT techniques, the broadband and audio MT techniques are other ones that are fantastic. So yeah, we're very grateful for whatever we can get, but yeah, that would be a wish list. Well,
I can help you out with that because we're planning some gravity and some new MT as well, sort of east of Cloncurry, and I'm not sure the geophysicists would have to tell you which areas precisely they're planning, but we are planning to collect more of those data sets in the region and particularly undercover.
Outstanding. Just look a little further north.
Oh, okay. All right, we've got some more questions. So obviously once they got warmed up, the audience had a lot to ask you, but I might move on now. And Stuart, if you don't mind, if you click on the Q&A tab at the bottom, you can type your answer and then publish it. And I think, Rick, everyone can see those answers, can't they?
Yep.
And the questions? Yeah.
Yep.
All right, so everybody can see Stuart's answers. But now, thank you very much for that.